Okay, like I said, I'm Nathan Smith. I work at Chef. I do mostly front-end development there, but I've been a sysadmin, and I do a lot of sysadmin stuff, working for a company that does a lot of sysadmin stuff. Uh, so, so I'm going to talk about DevOps and Chef. A lot of the things I'm talking about are very specific to Chef and the things that we're building and the things that we're trying to get people to use and buy from us. And but a lot of these ideas and the idea of ways to use software to successfully run your business can carry over through any tool. And so there's a whole ecosystem of tools like Docker, so thanks a lot for presenting that. So I'm just going to go through the nice thing about working at a company with a lot of other people who give talks at conferences is that you can just steal their slides and then take them to a meetup. But I will admit that...
I know you worked really hard for this.
I will admit that I didn't work that hard on this. I did change the name. The guy who gave me the slides, his name is Nathan also. So I did change the last name and the email address. But so I'll get started. And like I said, a lot of this applies to Chef. A lot of it doesn't. So you can kind of think of this as kind of a primer on DevOps in the key of Chef, maybe. And we'll get started. So a thing that's happening in the world right now is that every company is becoming a software company. We work with Alaska Airlines. I think the quote here, "We're going to be a software company with airplanes," is from the CIO of Alaska Airlines. You have Amazon, you have Google, you have Facebook, you have those type of things. But you have traditional companies like Gap and Target and GE and Nordstrom's who, they're a retailer, they sell clothes, but they're realizing that in order to be successful in the world today, you have to become a software company. I mean, if you look around even locally, if you look at Telefarm, like, they're a pharmacy company, but they're a software company because they're realizing that in this world, software is really what's enabling businesses to accelerate and compete with one another. But that does bring a lot of challenges with it. So this is a graph that kind of shows the historical trade-off. So you have quality or compliance on this axis, and then rate of innovation on this axis. So you can go fast and crappy, or you can be good and slow. So you kind of have to find this balance between quality and innovation, and make those trade-offs to see where you can get there. And so there's a lot of things that are kind of in the way, slowing you down, keeping you from being able to move as fast as you can and at the highest quality. So you have things like manual processes for setting up software. Those will slow you down. So instead of those, you can have solutions to these challenges. So automation, where you can take those manual processes where you had weeks to set up a new server, you can now have one set up in minutes or seconds with tools like Docker and Chef. So you have these legacy systems that are hard to make changes to, and moving to more dynamic infrastructure, the cloud and on-demand services, software as a service type offerings. Those can kind of free you from some of those legacy systems and allow you to move faster with higher quality. You have organizational silos where different departments are just separated. They can't or won't talk to each other. They don't communicate, so they don't work in a cooperative way. If they were cooperating, they could build higher quality stuff and do it faster. So you want teams that are aligned toward common goals, trust each other, and cooperate instead of teams that are siloed off. You have things like infrequent large releases. It's scary to deploy because you haven't done it in a month, and you have this huge batch of changes you want to put out there, but who knows what's going to break. So what you want instead is continuous delivery, where you're making a lot of small batch changes quickly, getting them out there incrementally and safely, instead of the big scary deployment. And then you have regulatory burden. So you have compliance. You make this thing happen, but then you have an auditor come in and tell you all this stuff is wrong. You need to go back and change this stuff. You need to be compliant with all these regulations and rules, and it's hard to do that, especially at the end of a project. So what you want to do is integrate compliance into your workflow throughout the whole process, so that you don't have to do this scary thing at the end. So all these things together are attributes of what makes up DevOps. I mean, DevOps, you could ask 5 people and get 6 different answers of what is DevOps. But these kinds of practices are some of the practices that comprise DevOps, and when you put them together and you do them, you can really increase the value that you're bringing. So instead of moving on this curve, what you can do if you adopt some of these practices is increase your quality in this direction and increase your innovation in this direction, and kind of move that curve so that you're able to go faster with higher quality. So dynamic infrastructure. Docker's a big part of this with containers. You also have things like EC2 or any cloud provider, where it makes you able to dynamically scale up and scale down, put resources out there in the cloud, and have that kind of flexibility where you can create and destroy things a lot faster. And I mean, the cloud's a pretty, cloud services and all this stuff is pretty mainstream now, so you've all used stuff like this. And then infrastructure as code. So, like what Chris was saying, where you have the wiki page with the instructions, that doesn't work. It never has. And so the Docker file that Chris was showing, that's a form of infrastructure as code, where you can take this software that describes your infrastructure and commit that, commit that to your source control repository along with the rest of your application code. So when you do that, you have a lot more safety, because instead of just running this, instead of having something written down that's going to go out of date, you have something that actually is executable, and you have something that you can run to automate those processes. This is kind of getting into some of the components of Chef, but so you can programmatically write code that describes what your infrastructure is going to look like, and then run that code to provision those components, and you treat it like your own code base. And a good way to tell if you're doing this correctly is, and it's not something you often need to exercise, but if a bomb hits your data center, if you have your GitHub repository, if you have a backup from your database, and you have your AWS keys, or you have access to compute resources, you should be able to reconstruct your entire business based on that code, that data, and that hardware. And you should be able to do it quickly if you have it all automated, and that's a very reassuring thing to have. Automation. We're talking about the infrastructure as code, and just the workflow and the installation of everything, and the policy and the management of interdependencies, that can all be caught in that code and made to be automated. So this is kind of how a picture of how a Chef server works. So over on the left you have your code repository that has the code that describes your infrastructure. You can upload that to a Chef server, and then you have we call them nodes, but they run a Chef client. So they run an agent on there that usually have that run periodically, and that will pull data from the Chef server. And so the Chef server is a database that has all this information about your infrastructure. The clients will pull down this data about how their node, what their state should be, and then they'll run these recipes, they're called, to make sure that the node is the state that we said it should be in the code. So each node is an independent actor, and it downloads the data it needs to converge to its state, and it does it periodically to make sure that it's up to date. So a node could be a server, it could be a VM, it could be a cloud instance, it could be there's some network hardware that runs Chef, so it could be a switch, or there's a lot of different things that could be a node, but something that runs Chef is going to be converging its state based on what the Chef server tells it to be. So if you kind of look at the workflow, you have your infrastructure layer where it's the hardware you're running on, which could be bare metal or Azure or Amazon, some sort of compute resources, and then above that you have runtime environments, and you have the applications that run in those runtime environments. So what we have with Chef is the Chef development kit, the Chef DK, and that's the this is what you run on your workstation, where you go through this cycle of building and modeling and testing this infrastructure. So there's tools in the Chef DK that let you spin up an EC2 instance or a Vagrant VM or a Docker container, and then run your tests the tests of your infrastructure in a development environment, and then you can test those locally and use them. So this is what some Chef code looks like. This is a recipe, and so this is setting up a web server. So the HTTPD is Apache, so you can have an Apache service running, and you want it to be created and started. You have an Apache configuration file, and it's coming from some kind of template, and it notifies. When that notifies means that when this configuration file changes, I want to restart the HTTP service. And then you can have another kind of resource is a directory. So these are kind of the basic building blocks that you're going to run on a machine. And what these are called are resources. So Chef recipes are an ordered list of resources, but you can put, it's the language is built on Ruby, so you can put any kind of Ruby code in a recipe. But essentially, you're going to have a list of resources, and then when you run the Chef client on this machine, it's going to go through these resources, and this here describes the state that you want the machine to be in. And so what Chef is going to do is going to go through and make that state happen. And I don't have like any really cool demos, but I can kind of show some really basic stuff and some examples of which kinds of resources are available in Chef. So like this is a really simple recipe, like about as simple as you get, but I have a file, I have a directory, and I have a package. So so what I'm saying is I want this file to exist, I want this directory to exist, I want it to have these permissions, I want this package to be installed. So on my local machine here, I can run the Chef client, and it's going to go and create. It's going to go and have an error. Of course. See, I told myself I wasn't gonna live demo anything. So now you can see that it's created this file here. It's updated the content. You can see a diff of what it changed in the file. It created a directory, this package. So you can see with some of these resources are kind of abstracted based on the platform. So I'm on a Mac, so I said package fish, which is the shell I use. So I'm on a Mac, so it decided that should be a homebrew package. And fish was already installed, so it didn't have to do anything. Now if I run that again, what it does is, it's trying to converge on this state here. So everything it does is test and repair. So when I run this again, it's really not going to do anything. It's just going to say, okay, this file already exists, and this directory is already there, and this package is already installed, so I just run through this and don't do anything. And so it says, 0 of 3 resources were updated. And that's the really basic stuff. If you look at the list of all the different resources, I mean, there's all kinds of, you can have a cron thing or a file or BFF packages are on AIX. So if you're running AIX, like, you can install your BFF packages. So these are all the built-in resources. And then, so DSC on Windows is a PowerShell thing that lets you control the state of a Windows machine. It's got Python stuff, Erlang stuff. So a whole bunch of built-in resources. And then there's a site where you can do, so there's a site called Supermarket, which has a bunch of publicly available cookbooks. So you got Java, MySQL, you got a bunch of different cookbooks that you can download and use for your own use. And so each of these cookbooks, a lot of these implement. Some of them have recipes that maybe just install MySQL or something like that. Other ones have custom resources. So the list I was showing you here, like these are all the built-in resources, but there's custom resources. So if you look at this, this is a Docker cookbook. So this implements custom resources where I can say, here's a Docker image that can pull. Here's a container that uses, comes from this image, runs this command. you can say, I don't know much about Docker, but there's there's all these, there's all these different Docker resources you can use. So if you want to manage your containers with Chef, then you install this cookbook. You can manage your containers with Chef instead of typing shell commands.
But you'd use the Docker.
It's almost like managing the Docker host with Chef.
Yeah, you could do that. So and with Docker and Chef, there's like, if you ask all the people that are using Docker and Chef together, people are using it in a lot of different ways to do a lot of different things. So this is kind of just an example of, these are anything can be a Chef resources. Anything that's a noun, essentially. Like I know there's a cookbook that manages like GitHub teams and GitHub users, and so you could write a Chef recipe that says like, I want this GitHub team to exist on my org, and I want these users to be members of the team, and pretty much anything that can be described as a noun can be a custom resource. So those are just a few examples to show.
Chef Docker store, is that the idea then that I would like use Chef to grab, basically, set up a new VM somewhere out there in the cloud, grab this Chef file to throw whatever VMs I need for my setup.
Yeah, you could describe the state of the VM that's running the containers. So the state is Docker needs to be installed, and then these containers need to be running with these dependencies and these directories need to exist, and these for the data mapping and everything.
And then kick off all these Docker files.
Yeah. Yeah.
So the upside to using Chef would be if you're having to, rather than keeping VM images or backups, which have to be, or baselines have to be maintained, you're able to update the binaries on
right.
Chef.
And what a lot of people do is, you kind of have a problem when you're using golden images because things change. So what a lot of people do is they'll build an ISO or an AMI or whatever. They'll build an image, but then they will run, they'll run Chef Client on it, like when they launch it, so that image might have to run some stuff to get updated, but it's not going to be, you don't have to recreate it from scratch, and you don't have to worry about the image being out of date because you have your Chef Client running on it that's going to converge it to the state that you want. So yeah, definitely that's a thing that you can do. And so we also since this is just code that we're running, we can also run tests on it. So what's shown here is called Chef Spec. So if you ever used Ruby RSpec, and Chef Spec is just a library for RSpec that lets you do. This is kind of for unit testing to kind of just test the inputs and the outputs. So it's not actually like installing when you run this test. So what it's saying here is, okay, for Apache, when I'm just using default attributes, a Chef run just converges. So I have an expectation that when I run Chef, it's not going to blow up, and it needs to install package Apache 2. So Chef Spec is for unit testing, so it's not actually going to try to install Apache. It's just going to execute that Chef code and make sure that, okay, these shortcuts here say expect to install package Apache 2. What that's saying is there is a package resource in this Chef run that says to install Apache 2. And so this is good. I mean, if you have a really simple recipe, it's obviously kind of redundant to just say install package Apache 2. Expect install package Apache 2. But if you get more complex recipes, you're going to have You're going to have different results with different platforms. Maybe if I'm on Red Hat, then it's called HTTPD, and once you have if statements up in there, then you're going to want to have some tests to make sure that whatever you're doing is doing what you expect. So Chef Spec is for unit testing. It's very, very fast and very, just make sure your recipe does what it says. So then we have, we had the Chef server, something managing your runtime in production, and then Chef DK on the client. And so, you have kind of this package where you have dynamic infrastructure, infrastructure as code, DevOps, and in this case, DevOps is kind of talking about kind of the cultural, the whole package, I guess. So DevOps, you start with automation. In order to do automation, you need code. You want to be able to version the things you do so you can roll forward and back. You want to be able to consistently create things. You want to have things testable. And all those things are true for infrastructure and for the business you're building the same way that they're true for the apps you're building. So DevOps can be defined as a cultural and professional movement focused on how we build and operate high-velocity organizations born from the experiences of its practitioners. See, I just read that slide.
That is a definition with no definition in it. It's amazing. Right? It doesn't actually...
Right, so it is, that's kind of what born from the experiences of its practitioners means. But, so that's why I kind of said this is kind of a Chef flavored thing. So this is how we at Chef define and do DevOps. And, you may do it differently, but a lot of things are still in common. So the people build the product that builds the company. So if you have unhappy people, they're going to build an unhappy product that builds an unhappy company. And if you have happy, productive, nice people, you're going to build happy, productive, nice products, and you're going to create a happy, productive, nice company. So the people are, the foundation of that. And another kind of tenet of DevOps is lean. So it means what this means is that you like to use a lot of Japanese words in your work. But actually, so there's a lot of history in manufacturing that started with the Toyota production system and how Toyota used some of these practices to build quality into their work. And there's a ton of stuff you can read about this. My favorite book on it is called The Goal, which is a business novel, which is like my favorite genre too. It's a novel about a guy working at a factory, and the factory is terrible, and it's going to shut down. This other guy comes and teaches him how to kind of do some of these practices and how to build systems that continuously improve, that build things in small batches, that encourage experimentation, that eliminate waste, that where work is pulled through the system instead of being shoved through the system. So there's a ton of reading on Toyota production system. It's all great stuff to learn about. Another thing that's important is handling failure in a humane way. So failure happens a lot in software. If you ever worked on software, you know this. My wife plays Game of War, and yesterday Game of War was down for like hours, and people were pissed. Like they were just, my game is down. What have you done to my life? You all are terrible people. I need my crack. And and so, and whenever I see software fail in public, Netflix is down and people can't do this, or Amazon EBS volumes had a huge choke event and it like took down half the internet. Like, you always gotta, if you work in the software industry, you gotta feel bad for like that guy who put that setting into the router wrong and like took down so much problems. And there's a lot of organizations where if you screw up, like you're done, you're out. Like you cost us a lot of money, you're out of here. And I think part of the DevOps culture is failure happens, we learn from failure, we allow failure, and when we handle it, we don't take it personally. We don't put blame personally on people. I can show kind of just a couple examples from Chef. So the supermarket I showed earlier is an open source project, and I think when was this? A couple weeks ago, there was something that changed, that an API that resolved dependencies was failing. So we we posted this on our website, and for products that are, if we cause an incident that was an open source product, then we have a post-mortem for it in public. So there's a Google Hangout, anybody can come and participate in this post-mortem meeting where we can figure out why things went wrong and what we can do to improve that. So this one was an example. There was just some API outage, and but they had a post-mortem in public, talked about it, and then privately, this is something I broke, and so this was back in March, and I'll just show you. This is from our internal post-mortems repo, where this is the document. And whenever there's an incident, which can be if we deploy something that has a defect in it and it affects customers, including internally, or if there's some operational outage, we have an incident process. We go through the incident. At the end of the incident, we build one of these post-mortem documents, and I can just show you kind of what it looks like. We start every post-mortem with following, and has these actions there that make the focus on what we can do to follow up and improve things, not on whose fault was this and when are we firing them. So pretty sure this was my fault. It was my team, and so we released Chef Manage, and we do a timeline. So somebody opened an issue saying they couldn't connect to a load balancer, and it was reporting that localhost was used. This is all just stuff specific to the issue, but we just went through and wrote out this timeline, and then at the end, we had a release, and we failed to consider the difference between these two variables, and what did we do to fix this? Who was impacted? People running this version who downloaded the starter kit, couldn't connect to their Chef server, and then what are the corrective actions? So we wrote a test for the thing we broke. We added something to our release instructions, and we changed some stuff about our repository. So we try to keep everything very positive and come to solutions that encourage, like, we're learning from this failure, it's okay. I mean, I do remember a few months ago in another outage that I caused, that I tweeted, the link to the blog post where I explained how I broke Chef, and and a friend of mine, replied to my Twitter, "Oh man, are you getting fired?" And the CTO, replied to him, "No man, you're not getting fired. We're gonna learn from our failures." So we try to be like. I find it awesome to work at a place that actually lives these values, because it can be scary when you screw stuff up. And in order to have trust in a company, you need to be able to allow that. So ubiquitous workflow automation, I think we talked a lot about that. You can make donuts.
Chef.
Sure.
Well,
A donut resource.
you can make donuts. You can make donuts, but if you want to make a lot of donuts, you have to automate that. And you can make software, but if you want to make a lot of software, or a lot of whatever it is your company makes, you're going to have to do automation.
So I worked in I did a one volunteer day making mini donuts at Valley Fair. I still smell it. Just seeing that picture was oh, I feel the grease. It was terrible.
I don't know. I'd like to try that. I like donuts. I still smell like
Great
pizza and
until you
garlic.
have to sit and make them for 8 hours, and then different experience.
Diversity is another thing we value, because when you're building something, if you have the same type of people with the same type of opinions and the same types of experience, you're going to miss out on a lot of stuff. And I think the tech industry is clearly a place where gender and ethnic diversity is not happening in a lot of places. If I look around, but I think that all of the things that come from diversity, I don't consider it an end in itself necessarily, but the benefits you get from having multiple people with multiple backgrounds, multiple opinions, is very valuable, and that's just part of the mix. So the rewards of all this stuff put together, and this is based on some DevOps research that's been done by surveying a bunch of companies, but more deployments, you ship more often, smaller batches, you ship faster, you have a faster mean time to recovery after issues. So you want to be measuring, instead of measuring how often it is between failures, you want a key measurement to be when you do fail, because you will, because you're building distributed systems in pretty much everything you do, and they will fail. How long does it take you to recover? And you want that to be faster. And if you implement these practices, that will lead you toward faster mean time recovery, more money, more market share, more productivity, more market cap. And so if you want to sell DevOps to your boss, tell them that it makes you more money. So you put these things together, you have a lot of these things we've already talked about, but you end up with an advanced high velocity workflow. And we have the testing, integrating security and compliance into the product development. So then there's this middle piece about this is a newer thing that we have up called Chef Delivery, and that's kind of the piece about, so in your local development environment, you're building and you're modeling and testing. In Chef Delivery, you're running those tests in like a CI environment, and then you're building artifacts, and you're deploying software, and then that goes out to production, where you have your production infrastructure managed by Chef, and your other runtime management stuff. running all that. So kind of this picture right here, this is the bar you see in Chef Delivery, and this is the deployment pipeline. This is the continuous delivery pipeline, and so this pipeline is fixed. So this is the way your pipeline works. If you use Chef Delivery, it looks like this. No matter what you're building, it looks like this. And it's designed, it's been designed this way based on work we've done with lots of customers, and we've figured out this is the best way to deliver software through a pipeline. So this part is fixed, it's flexible. Like I'll show you within each of these phases, stages. They're called stages. Which within each of these stages, it's flexible what you can do in each stage. But everything goes through the same workflow. Your application code, your infrastructure code, and everything goes through the workflow. So you can see this is kind of a different view of the pipeline where you have different applications or cookbooks. So the cookbooks will have your infrastructure code, your applications will be application code. You have pipelines for each of those, and then if these are dependent things making up an entire system, then the pipeline puts them all together in an environment called union, and make sure that all of these things, all the different components work together. So if you change something in A, change something in B, run tests in this union environment, it'll reveal that there was something in that dependency that broke something, which you will learn about before you get to delivered, which is where your customers are using it. So in this pipeline, you're building in some safety and building in how you integrate these components and how you have a workflow for making changes to each of them individually. So, these are some of the values around continuous delivery, where you want to be able to have your dev and test environment fast. You want to make sure that these environments, as well as your production environments, are consistent and repeatable. And you want to have a unified pipeline for everything that goes through. And you want to be able to do it for large teams. And again, you get this advanced high velocity workflow. So that's the delivery piece, and then and I can show a little bit of Chef Delivery. So we have so there's our docs, Chef Docs site, and we deliver the docs site using delivery. So in delivery, you have your verify stage, and then each of these phases inside the stage are things that you run. So every time, we have some GitHub integration, so pretty much you can kind of think of the verify stage as similar to what Travis does, where you're running your unit tests. So for every pull request or change request, it's gonna run these basic unit tests across things, and then you're gonna have one of your manual gates here where you want something to be approved, and then so you can. This is like the actual thing, so I'm not gonna click that button. It's probably fine, but
We don't want you to have to update Twitter tomorrow.
Yeah, I don't want to. Writing postmortems is a drag too. But you can see kind of the output here, and the unit. This is just a doc site, so these things aren't that exciting. But then once this gets approved, it goes into the build phase, which runs these tests again. But then there's also, you can have some quality and security phases, and then you have a publish, which will do, the publish phase is what builds an artifact that you're going to deploy. That's really long. There's a lot of docs. Alright. And then once it goes through that publish thing, then it goes into an acceptance environment, which, for this, I think we have docs, acceptance. So, we have this acceptance environment where someone can actually go to it, it's going to deploy to an environment, someone can go there, make sure that the change that went through was, is accepted. And then once it's in that acceptance environment, we can also run some smoke and some functional tests to do some testing in that production-like environment. And once that's done, you can deliver, then it goes into the union, rehearsal, and delivered stages where, if there's dependencies, they get pulled together. And then, so if you look at each of these phases right here, in the Chef Docs repo, there's a chef cookbook that has some recipes, and we have provision, publish, quality, smoke, syntax, unit. So each of those phases is a chef recipe. So if we look at publishing the doc site, what we do is we have a resource for an S3 bucket that ensures that so the docs are hosted on S3, and we have a CDN in front of them. We do some stuff, but that kind of gets it ready for publishing, and then not that familiar with these, but we copy things over to S3, so this just does an S3 sync of all the files up to S3. We do some stuff to make sure that redirects are there. We run Fastly, CDN in front of it, so we do a Fastly purge so that we clear the cache, the CDN, so that this is all done. So we have chef recipes. So any chef stuff you can do, you do in these build cookbook recipes, and then when you run your stuff through delivery, it runs all these tests. So we run a lot of internal stuff with it. It's pretty new. It's gonna be general availability pretty soon. And there might be an exciting day next week where you hear stuff. Potentially, yes. So another piece we have the delivery, we have the server. And another thing, and this is obviously not specific to Chef, but specific to any environment you're running. You want to have insight into what is happening in this environment. So that's our piece of that is Chef Analytics, where all the stuff that's happening, if someone changes a Chef cookbook, or a user uploads a new version of something, or if somebody makes a change to some piece of data in the Chef server, we're capturing all of that, and then you can write alerts to send events to it. You can send all the data to Splunk if you use that. You can send it to Slack or HipChat. And then you can also use it for some compliance stuff, which is what I'll talk about next. So, a lot of people work in environments where compliance needs to happen, and so I've had to do. Is anyone here had to fill out the like PCI compliance? Oh man, you guys are lucky. Yeah, it's pretty bad. But what happens is like you got your application out into production, and then now it's like, oh, we got to be compliant, and so some third party, either somebody in your company or somebody outside your company comes and looks at your stuff and tells you, here's what's got to happen. And if you do that at the end, like, it's a huge pain, right? Because they're telling you to do all this stuff. If you would have known earlier, you would have done this. So, if you're gonna think of, DevOps is about, you take the operations people running the infrastructure, you take the dev people running, doing the application development. You tear down the walls and you make them like they used to hate each other, and you make them buds, and everybody is happy together. Well, you do that, but then you still have those mean security guys who are like coming over and telling us to like look at him, he's so mean. He's here making us do all this stuff. What a jerk. And so you wanna tear that wall down too. You want your security guy like doesn't like to log into your box and run shell scripts on it. Like,
That's a
maybe.
lie.
Oh, you do.
Well, for one thing I could trip you up on, but that's okay.
But like, the compliance people aren't doing compliance just to be dicks. They want you. The compliance is there for a reason, and you want to work together, and you want it to be a good experience. And so that's not really the case now in a lot of places. So we're building some tools, and if you're not using our tools, like philosophically, like you should try and get along with your security people and make everybody buds. But in Chef we have in your recipes, in addition to resources, you have controls, and if you've done RSpec, you can see that this looks a lot like RSpec. That's because it's RSpec. So you can put these controls into your Chef recipes that say, oh yeah, SSHD should not be using protocol 1. So you can put tests that tell you to do this. Oh, go ahead.
Can I ask you a question about this? So, can you run that on any machine and it goes and looks at the configuration that's on the machine to
Yeah.
verify that? It doesn't have to like look at the recipe. It verifies it against what's on the machine.
Right. So a lot of what we're doing with this is called audit mode. A lot of what we're doing is people have infrastructure that they're not managing with Chef. But they want to manage it with Chef, but they want to make sure it's compliant. So you can run, there's an audit only mode that you can run where it doesn't make any changes, it only runs these tests. Or there's the normal audit mode where it runs the Chef code, and then when that's done, it runs the test to verify it. Or the controls, this auditor language, I guess. So you can be running just the controls that aren't changing the state of your system, just observing it, and then when this is done, it's going to report back to Chef Analytics, where you can see, oh, okay, like these nodes like aren't configured correctly, and so these ones need to be changed. So it's a good like stepping stone to like going from just observing the state of the system to managing the state of the system.
So to that end, are those signatures something that the company would define internally, or the recipes out there, or have you all inherited something like SCAP compliance as far as your signatures are concerned?
So these examples are probably just going to be something internal.
Okay.
But there are some cookbooks.
Sorry, cookbooks. Yeah.
So there's one called. There's one called CIS. I don't know what that stands for, so I'm gonna Google it right now. Center for Internet Security. So they have a set of security standards where that, you know, so in these examples, these are the CIS standards, and so you can say temp needs to be on a separate partition, it needs to have no view option, it needs, you know, so these are like these are real like Linux security expectations. So you can run this on a machine, and it'll tell you, you know, how CIS compliant it is. Which I'm sure all of your machines will just totally pass this, right?
Prepare to be disappointed.
So you know this is this is for CentOS. And there's a version for Ubuntu, but you know it's checking that GPG is turned on in Yum, and that Yum check update runs. You know, so these are you know, this is the CIS benchmark that you can run, and it'll do that stuff for all modes.
A lot of the controls do look like they are SCAP or derived from SCAP, but I'll have to go back and look a little bit more. If you're going for a FedRAMP or any sort of federated regulatory compliance beyond PCI or HIPAA, you're probably looking at SCAP as your baseline for your baseline configuration. So for anybody who doesn't know that.
And the idea here is like you work with, you know, whoever's doing your auditing stuff internally, and you can hand them the output showing, you know, look, all these things passed, and these are the things we're testing for. These are the things you want. Here's where we're verifying that those are all true, and it makes, you know, it makes a lot of that stuff much better. I think I'm running low on battery. So, sorry.
You guys that probably know more about this than I do, is there anything like that audit out there?
Yeah.
Is it
Nessus, Nessus, iDigital Retina, Bellark, and about a half dozen others. But those are the top three. Those have all seen some action in the government space.
Yeah,
really expensive things?
Nessus is not too bad, and there's a free version that you can use just for testing purposes, but you don't get all the signatures. If you're Retina, I don't know. I just go download it from the military website whenever I need to go run it. Bellark, there's a free version that's a local install.
Okay. I haven't heard of that one.
Yeah, it's not a very well known one. I think their enterprise version is probably a pretty penny, but it's
Okay.
but yeah, that's and that's the one I personally use on my personal computer just to check compliance on.
What's it called?
Bellark, BELARC.
And-
That one is only, or at least the local install is only for Windows. I don't know what they do for Linux.
Yeah, and a lot of these tools are going to be, you know, a lot of the off-the-shelf tools will probably do the like CIS scan for you. But you know, if you're at a big corporation and you guys have some internal compliance regime that has all of its own rules, you know, you're gonna have doing it off the shelf things, you know, not gonna do everything for you. So this is an example of Shell Shock. Everybody remember Shell Shock?
This is a hell of a graphic for pro chef, you know, kind of a thing. 'Cause
Yeah. So this
timelines look pretty sweet.
is major financial institution, and if you actually, I don't know which one. I don't know what the real name of it is. So, like, I could probably find out, but
It's probably
there's
being recorded.
yeah, it's being recorded. So come on.
We're not
Yes.
experts of it in.
So yeah, we had we worked with them to patch this vulnerability, and you know we have their 60,000 servers that weren't using Chef. That, you know, there were 144 work hours needed to identify vulnerability and 8 hours to identify. So that means like a bunch of people. And then took 5 days to patch all the servers. But they were running Chef with analytics, and their systems reported back. They put in an alert saying, hey, if you come across a node that's running this vulnerable version of, what was that, Bash, then, send an alert. So they wrote a cookbook that made sure that the right version of Bash was installed, deployed to all their servers, 10 minutes, like, you're good. So, yeah, that is a good slide. A big part of Chef is our community. Chef.
Come on. Come on.
The Chef client is the Chef client and Chef server are open source, and delivery and analytics are premium closed source products. But Chef was built as an open source tool, and we have a big open source community. And Chef the company does not exist without the Chef the community. And we're building something bigger than just the company, something bigger than just ourselves. And it's very. I came back a week ago. I was at. We have a Chef community summit, so it's about 300 contributors to Chef and Chef employees, and we all get together and we fight. No, we get together and we have an open spaces conference, and we learn a bunch of stuff, and we come up with a bunch of great ideas for how to move stuff forward. We argue about the best ways to do things, and it's great being part of a community. So even if you don't work for Chef, or even if you don't pay for Chef, like it's all one community and diverse people, and it's awesome. And and this is some stuff we do about forming communities. We go into big companies and do some workshops with them for how to run, how to make this transformation into like doing DevOps. Like it's a whole company. You can start out with a DevOps department, but that's got to be a temporary thing. It has to be something that comes up from the bottom and is driven from the executive level down. So we go in and we work with companies to train them and to help them make this transformation. So there's some conferences around. There's one in Chicago, there's one in Minneapolis, and all over the country, but they have DevOps days. I haven't been to one yet, but they're I've heard great things about them. So
you get to sponsor local meetups.
yeah.
Sweet. I know you're talking.
And so, but with these DevOps days, we also have gone into some pretty big companies and done like a DevOps days, like at this company with just the employees, to kind of, get everybody pumped up and, talking to each other. You get a bunch of people from a bunch of different departments who normally don't talk to each other. You get together and you all talk about, oh, you're using Vagrant? I'm using Vagrant too. Oh, that's awesome. Docker? What's that? And so it's a great way to kind of build. You have these communities. We have our community here in Iowa City. You have the community, the people you work with in your company. And so to build these communities that work together and share and talk to each other and make great things happen is a really important thing. So when do we do this? Right now.
We're doing it now.
Yeah. And so that's all the slides I got. Is there any questions I can answer?
You pointed out that you have like the recipes, and they go to the Chef server, and then they propagate out to basically all the clients
Right.
that have it. I used to work at an enterprise, and that would scare the hell out of our operations people from the standpoint if they would want to have like death grip on that server, and somebody sends the wrong thing and propagates out to all the clients.
Mm-hmm.
Is there like a approval process on there, or like what?
Well, I mean, you can use Chef Delivery.
Not
But
yet-
also,
Not yet you can.
well, yeah, I mean, just, yeah, you can, you're good. But you can, part of that is the testing workflow,
Okay.
where you can write, so you have your chef spec, and there's also a tool called Test Kitchen, which will actually like run the stuff in a VM. So like the chef spec test I showed, like just simulates running the Ruby code, but if you run it in Test Kitchen, that's going to spin up a VM or a Docker container or whatever, and like install Apache, and then you can say, oh, is port 80 open? You know, so you can have some tests around that. You can, with the Chef server, it has ways of controlling the policy where these are the versions of the cookbooks that are allowed in my pre-production environment, and when I want in my production environment, these are the versions that are allowed. So you could bump the version in your pre-prod, make sure that everything okay, and then like lock the versions down in production to make sure that people can't just push up code and then like change the production environment. It has to go through some kind of gates where it's promoted. I mean, you can run your production environment with everything on master, but my ops department doesn't let me do that.
Yeah, I'd say if anything, from the couple of enterprises that I've been in, every single one where there's been an opportunity for the sysadmins to hold that environment close, they've been slow and horrifically inefficient because they're doing their own testing and their own blessing of their own stuff, and then a guy like me will come behind them and start auditing their progress, and they're just woefully. They're behind every single time. They're surprised that I'm finding things. I'm like, well, if you just followed the test wickets and all the SQA process that the other two departments did, you wouldn't be in this problem. Every single time, that's been the outcome.
But
So
you guys
it
should
just
be
means good discipline. It just means good discipline on your people party politics side. Forget the technology.
Right. Yeah. And I think, if you have ops people who are reluctant to make automation happen, like, I don't know, they should try it because and another thing is, when I first started using Chef, there's a time where it's like, oh, something, I need to change something, like, forget that stupid Chef thing, like, I'm just gonna go like edit the configuration file myself on the box, and then the Chef client's running, so the Chef client runs a couple minutes later, and it's like, wait a minute, that's not supposed to look like that. Changes it back, and then I'm like, God, stupid Chef. Changing my thing back, but then, you learn that, oh yeah, maybe I should, like, test this change locally, make sure it does what I think it does, and then do it in production. And so, I think, and then with that gives your ops team more control, because not, if somebody had root SSH to a box, even if they did go in and edit something, like,
Be back in a second.
it wouldn't stay that way for long. Does that answer your question? Cool. Anything else?
More questions at the mill?
I wanted to tie a couple of things together. So, thank you. I can't wait to install this because this is exactly what I wanted. And I think the thing that I've learned from this tonight is that no matter what the tools are, there's no substitute for like a good sysadmin that knows what he's doing on that thing, right? You have to have that knowledge from someone to lock the thing down. But with Chef, you can have that guy do a lot more because it can automate a lot of things for him. And the thing that Docker brings is it lets him keep all the different things that he's managing isolated from each other, so it reduces the complexity of what he has to look at any given point in time. So I think that's how they all tie in together and complement. Maybe.
Yeah,
I don't know.
no,
That's,
totally.
It's close.
That's what I
Um,
gleaned from listening.
yeah,
to
so
everyone tonight, so
It-
thank you.
It definitely provides a good workflow to do it right, because the manual way, you get to do it whatever fuck all way you want, and that's the hard way to do it.
right. And yeah, so I live in Iowa City. I work at the collab over there, and I work at Chef. So if there's something about Chef or DevOps or anything, like if I don't know it, I work with people who do.